Lesson 6, generating and displaying the execution plans. After you completed this lesson, you should be able to discuss execution plans. We've already had a little look at them. We want to build on your knowledge and add a little more details. We also would like you to understand how to gather the execution plans and then find out where you can get them from and then actually display them, because they give us lots of useful information about the processing of our SQL statement. So first up is execution plans. What is there? How to read them, reviewing an execution plan, some things to look for, and how do we view them? Okay, so first up is, what is an execution plan? The execution plan of an SQL statement is a composite of small building blocks called row sources for serial execution. At some point, we have to get the data from the tables, but then we can start doing transforms on it, joining it with other tables, grouping it, etc. By using a parent-child relationship, the execution plans can be displayed in a tree-like structure, either as listed text or graphics. By using parent-child relationship, the execution plans can be displayed in a tree structure. We saw a brief example of that in the previous chapter, graphically, or we can do it as a text version, that is our indented version, when we had a look at the output of the explain plan. An execution plan includes an access path for each table. If we can use an index because we're reducing the data, okay, with a filter, that's great. If not, it can always do a full table scan. An ordering of the tables, the join order that we're going to join them in, and the appropriate join method to join pairs of tables together. Reading an execution plan, the operations in the execution plan are read from right to left, from top to bottom. Okay, we'll show you a little flow chart to see how to read them shortly. And this is a look at a output from a plan table. We can go and collect it from the plan table that we've done an explain plan statement to, and we can call a little package that we introduced in the database called DBMS XPlan, what was introduced back in 9.2. And the first thing you know how to do is look what's in the plan table. To get information in the plan table, we can use the explain plan statement. It's just another SQL statement. And it has a number of options. The most basic is for and then a statement you want the execution plan. The set the statement ID is really optional. If you want to store a number of statements in a plan table, then you can give them individual statement IDs. And then when you retrieve, you could ask for a particular one based on their statement ID. It's actually just easy not to put it on, put one in, and then clean it out by truncating the plan table between runs that I find. And there are different levels of information it can provide. In this case, we want the fairly basics. It gives us basically the execution plan. In this case, when we were querying the employees number from the employee table, using a like function on the phone number, it did a full table scan on the employees table in this case. So it'll give us an idea how we're accessing the data to solve this query. And the name beside the table access full, which is their way of expressing a full table scan, is the name of the table we're actually scanning. By having a look at the execution plan, we can review them and decide if it picked a suboptimal plan or made reasonable assumptions. The suboptimal plan could be made because of wrong assumptions, errors in calculations, or errors in input. It has not up-to-date, accurate statistics for the database. Okay. The first thing we said, derive from the tables that have the most selective filter. the ones we can reduce the table the most. When we had a look at our join, when we did the 1053, we had two tables. Neither of them had a filter to reduce their data, so we drove from the smaller the table because it has the least number of rows that we have to join with the other table. And it was as good as going the other way. Turned out that the best cost we got was doing a hash join either way, so it picked the smaller table. So check that the driving table has the best filters. Make sure we haven't missed a filter in the statement. Just return the data the application needs now when you're developing the SQL. The fewest numbers of rows that are needed to solve the query are returned to the next step. A full table scan is more expensive than using an index because we reduce the cost of getting a reduced set of rows if we're looking at a small subset. The join method is appropriate for the number of rows. We're going to see a little more details to really make decisions around some of these. We still need a little more details around the join methods and when they're useful and what conditions that are good for and they're not good for. So we're going to see more details, but these are one of the things you'll eventually understand. Make sure the views are used correctly. Don't use them in the wrong context. Do interesting things like I did, pick 2 out of 9 tables being joined, which is inefficient. I should have put a view just on the 2 tables that I was interested in, not reuse an existing view. Generally, Cartesian cross products aren't generally useful for applications. Generally, they really mean we missed the join condition in a statement generally. There are very few exceptions to that, but there are exceptions. But generally question if you see a Cartesian cross product as part of the processing of a SQL statement for a practical application. And the tables are accessed using the most efficient access path available. So where can we find them? We can find them everywhere. It used to be relatively difficult. Prior to 9.2, there was a limited number of ways you could get them. Okay, now there are many ways to get them. We already showed you can get them with the explain plan command. You can go and see if you have the privileges to access the $V views, what's being run in memory right now. That's what's in the library cache, whatever is our shareable SQL. There's usually a lot of statements in there for big databases. We usually want to look at a small subset of the data. $SQL Plan Monitor was a new feature in 11G where we can monitor long-running SQL statements, and it includes the execution plan. We write them down to the AWRs, or there's a DBA view that can be used to access them. And the stats pack, if you're running on the standard edition, you don't have access to the AWR, but the stats pack, okay, has a report where you can pull up the execution plan for a set of statements. And just like the AWR, normally we sample 10%, the 10% most expensive statements. And the stats pack does the same thing when it's run and it samples. It does a similar thing, creates samples. Probably once an hour is useful. And then we can run the report. Both of them, you can set them to 100% of the statement. And the only thing that would limit that is the shared pool. Okay, if the SGA isn't big enough to make the library cache big enough to make the shared pool big enough to keep them, all the statements in memory between snapshots. SQL Management Base now contains the execution plans. Okay, SQL tuning sets include the execution plans, creating a trace file. At the end of the 153 trace that we saw in the practice for lesson 5, they have the execution plans at the very end of it. And starting in 10G release 2, if somebody does a process dump on a process, it includes the execution plans for all the statements that that process was running at the time it was dumped. Now, how can we look at them? We know where they are. How do we get at them? Well, the easiest way in most cases is to look at the plan table. okay, and to use the DBMS XPlan, you can get them out of the plan table by using DBMS XPlan display. It was the original method. AutoTrace will also display them, and I gave a little demo of that earlier on when we were looking at one of the practices. And you can go see what's in the memory right now in the library cache. You can go see what's in the AWR. It's possible to dump it from a SQL tuning set. And the last one we added is being able to dump it from the SQL plan baseline, and the plan baseline was new in 11G of the database. Next up is the explain plan command, a little bit more details about it. It generates a optimizer execution plan, stores it in the plan table, and it used to be we had to create the plan table. It's all automatically created, but it does not execute the statement at this time, which is an advantage if you just want to see what the execution plan the optimizer would use now. I think it's a pretty significant advantage. Okay, this is its full syntax. Explain plan is a required keyword. It's the name of the statement. Optionally, these are little railroad bars. You can go straight through without the optional, or optionally you can include set statement ID. Optionally, you can tell us the plan table you want to use, but generally you won't have to do that now. And finally, you need to say the keyword for in the statement. So really what you need is explain plan for, and then the statement gets replaced by the SQL statement you want to get the explain plan for. So this was a little example. Once again, they like to set their statement ID. Explain plan set statement ID demo. Did it. We didn't tell it where the plan table, starting in 11G, the plan table is created as a global temporary table everybody can share out of the box. So you used to have to create it. You could create your own still because the script file still exists, but generally I don't believe there should be any reason why you should have to typically. If you got a good reason, you may want to. The plan table automatically created these days. If you wanted to have your own, not use the global temporary table we create, you can go under the Oracle Home. Under RDBMS, under admin, there is utlxplan.sql. That will create a plan table into a particular account. And as we mentioned, advantage is not executed. The disadvantage is it's what the optimizer would use when you do the explain plan command. Not what it might have used last night at 3 o'clock in the morning for a batch job, or last week when it was running during the daytime. It's what it would use right now. If the schema has been changed, we've added or removed indexes, the access path could change from when the query ran to when we look at it now. Be a little careful with that. You can get fooled sometimes. It's actually a hierarchical table, and the hierarchy is formed with two tables, the parent ID and an ID. Every row has an ID. Here's my row number in the plan, and here's my parent. And the row at the very top doesn't have a parent, has a blank parent ID. And we use that to form the hierarchy and to form a tree structure. We can dump them out once we've done the explain plan. So we're doing an explain plan for a select statement. We called it demo 1. Okay, and if we get the syntax right, we get the message back explained. That meant that the optimizer went through and decided on which execution plan it would use right now. Then we want to display it because it put it in a plan table. Since we didn't mention it, the default one. We're going to make sure it doesn't wrap when we look at the execution plan. It makes them a little harder to read. So we're just setting up a few environment variables to do some formatting. Line size 130, page size 0, so we don't get any page breaks. Some of them get long. This one isn't particularly long, but some of them get quite long. And then we just call DBMS XPlan display. Technically, it's a table function. So you can use the table function on it, and then you can just form it in a query. Okay, and it will take the results, a little report that dumps out the execution plan from the plan table and make it look like we're querying it from a table. That makes it kind of convenient to look at. So we get the ID. So the top, the select statement has statement ID 0. That's what we're doing, an SQL statement. The first step within it is indented under it, so it says this gets done first. We're doing a table access full of the employees table. The rest of it is estimates. Okay, this is the estimated number of rows it's expecting to return for the first step, which is return to the whole statement. This is the estimated number of bytes that each row is in the employee table. And one of the things we calculate is average row length to use for this estimate when we collect statistics on the table. If not, it just has a fixed number. It really doesn't fit most tables. We just had to pick one. Okay, the next is the cost of doing this particular step, which was the only step in the execution plan. So the total cost of the statement was the same. So we calculate it, the cost is 3 standard I/O units for this statement. The CPU we're going to use during it was less than 1%, so it shows up as 0. And this is the estimated time. We're estimating about 1/100th of a second to do our 3 I/Os to complete the statement or have our cost of 3. Okay, there is additional information you can dump. There are a group of parameters for it. The last one says the details. So when you do all information, and there are other options, it gives you other information. What it does is dump a little more details. The first part looks like before. We also give you the official name of this query block. It's treated as one query block. It's officially called emp@select $1. Interesting name, but it's a manufactured name for it. Okay, next up is the filter condition. How we went in and have a look at the rows. We did a full table scan, we retrieved each row. We couldn't find an index to use for it. So we had to apply this filter to every row in the table. Then we show you the column projections, which is basically the list of columns on the employee table in the order they're returned and their data types, okay, which we could have got from a describe of the table. And we can get some advanced information asking for the projections, the predicates, and the aliases. Give us the execution plan. But when you do this, it gives you all the information you would need to set in an outline to guarantee that the optimizer would always execute the statement as a full table scan. Okay, so this is how you would create an outline, but outlines have been deprecated in 12c. So it's kind of interesting we show you when it's actually a deprecated feature. We think the SQL plan baseline does a better job of protecting you from regressions, because this was intended to protect from regressions, but it had the negative effect, it protected you from positive improvements in the optimizer. It's the only way we'll do it if there's an outline for it. And it implies high level of maintenance. Every time you upgrade the database, you should try any statement that has an outline, you should try it without the outline to see if it actually still needs the outline. Okay, so plan baselines get rid of it. It allows to see positive improvement while protecting from regressions. We also already gave you a short little demo during the earlier practice when we were looking at practice for 5 and having a look at the execution plans for a particular statement. Actually, that was practice 4, not 5. Okay, and we just needed to click on the 4th button over, and it will show us the outline. It was for a different statement. This was a join of the employee to the department table. In this case, it decided to do it as a merge join using an index because it found that we had a filter, email like a %. It can actually use a index on the email to solve this. So it used the index as a filter to filter it and did on the one side on the employees table, and it did a table access, full table access on the other side. Okay, and by doing this index, it was able to get the data sorted, to do the sort merge on one side so it didn't have to sort it. Oh, just a little example of another way of getting a hold of them. So we have a quiz. The question is, an explain plan command executes the statement and inserts the plan used by the optimizer into the table. So the options are true or false. We'll give you a moment to contemplate it. This is actually false. It doesn't execute the command. That was one of the advantages we said. You don't have to wait for it to execution. Okay, it builds what the optimizer would use right now if it was going to execute it and parse it and execute it right now, but without executing. So it gives the advantage. It's a quick way to get the execution plan that the optimizer might want to use now. The disadvantage is it doesn't give you any runtime statistics, and it might not be the plan used in the past. If something has changed, you've added or dropped indexes, so be careful with it. Second quiz. Okay, we want to know which of the following is not true about the plan table. So we give you a number of options. The first option is A, the plan table is automatically created to hold the explain plan output. I'll allow you to contemplate whether that's true or false for a moment. And the answer is this is actually true. Start in 11G, it gets created automatically. You don't really need to create your own in most cases. Number B is you cannot create your own plan table. Now that you've had a moment to consider it, this is false. Even though we create one automatically, if you really wanted to, you can go and create your own, and then you can point us to use that one. Number C, we'll read it and give you a moment to contemplate. The actual SQL statement is not executed. So that one is true. It doesn't match what we were looking for. We were looking for not true. Number D, the plan in the plan table may not be the actual execution plan. So this is also true also. Be careful if there's a large difference in time between when you did the explain plan and when you're looking at information about what the batch job was doing in the past. The longer the time is, the more likely something's changed. So it may not be the execution plan. The one that isn't true is you can always create your own plan table. So that's the one that's not true in this case. The other three are actually true. Next up is a little look at AutoTrace. Okay, it was a nice new feature in SQL Plus. In 7.3 of SQL Plus, we added it to the SQL Developer quite a bit later. Okay, SQL Developer is a fairly recent innovation. It needs a plan table, but we now have the automatically created one it can use. And we also need some privileges on some $V views to get a look at the things, how things have just been running. And we've wrapped those privileges you need into a role to make it easy for DBAs to give it to people. So we have the plus trace role that encapsulates those privileges. Okay, it produces the execution plan and statistics by default after running the query. It may not be the execution plan that the optimizer would use if the optimizer does bind peaking. They have an issue with bind peaking with this. So be careful with that. We wanted to give you the downsides too of some of these. Autotrace syntax. So I had a look at this when I was demoing it in SQL+. I got it to print it out. This is just what it had. You can turn it on. You get everything. You can say trace only. Okay, and if you do that, you get the execution plan and the statistics. If you say trace only explain, you only get the execution plan. If you say trace only statistics, you only get the statistics. And you should really play around with the options. I kind of like the trace only explain just to get the execution plan. It makes it convenient when you're using SQL+. If you can't remember what you set it to, you can always do show autotrace. The default behavior is off. Once you turn it on in any form, you can always turn it off again. And if you forget to turn it off and you have a look at DBMS_XPlan, one of the display functions, you get a really interesting execution plan. It's usually because if you see something called the pickler, it's because you did a call to DBMS XPlan and you probably forgot to turn off tracing before you did it. Because part of its process it uses something called the pickler, which is really interesting when you see it. So these were just some examples. The one I used was this one. They gave you some example statistics. Gets you the row and the statistics. If you turn it off, you get everything. You get the execution, the row output. You get the explain plan, how we went after it. Okay, and we get the statistics. If you say statistics only, you get the rows and statistics. Trace only, it suppresses the rows but gives you execution plan and the statistics. Some people like this one. It's a little less tracing, and sometimes the statistics are mildly interesting. So this was an example of turning it on, and they wanted the statistics only. Shows in the output, this happens to be a count, I guess. So it said there was 288 rows returned. And then it gives you some limited statistics in SQL+. The number of recursive calls that were called during this, how many blocks we got in DB blocks in get mode. That's in current mode. In consistent mode is query mode. These are logical reads. Then we have physical reads. And then everything we wanted, we were looking at 413 blocks in query mode. We didn't do any physical reads, so they were all buffered in the database buffer cache. We didn't have to read them off the disk. Gives you the redo size, and it's a query. So, because we're just selecting star from the OEM products. So we're not really doing any changes, so we don't expect any redo. How much data was sent to the client? How much data was received from the client? Usually we send more than we receive, generally, but not always true. How many round trips to do this statement? And it's quite chatty. This is not unusual. A, because it does usually, if it's a reasonable amount of data, it will do a number of fetches. But even before that, the SQL+ and the dedicated server chat back and forth. How much sorting was done in memory and how much was done to disk? Memory sorting is generally much cheaper than sorting the disk. Okay, and then how many rows? And we got that from the results anyways, but it just shows us. If we don't look at the results, it will show you the number of rows that is actually looking. If it returns a large number of rows, it's kind of nice to turn off the row output being returned. Okay, it makes it a little easier to read. Autotrace using SQL+. It's the third icon over. They forgot to put the square around it in this case. Autotrace is the third one. Explain plan is the fourth one. Okay, you just get used to where they are. Okay, and it will show you the execution plan. You can even see the output. but it also gives you the statistics, and they showed you just about what they showed you in SQL Plus. But in reality, there's a lot more. If you go and scroll down on this, if you take a look at one, you'll find there's a lot more statistics that SQL Plus gives you back than SQL Developer gives you back than SQL Plus does, generally. So we have a question on this. The question is, a user needs to be granted some specialized privileges to generate an auto trace statistics. True or false? We'll let you contemplate it for a moment. And the answer is true. That's why we have the plus trace role.